So, welcome everyone to our Gnoland workshop, how to build a forum in Gnoland. This is one of our first workshops I think we've done. Miloš, it's maybe your first workshop you've done with us?
Yes.
Okay.
Yeah,
So,
it's the first one we're doing.
yeah, and so if you guys have feedback for us on how this goes, let us know. Also, we'll post this online, so you'll have access to it if there's anything. The HackMD, I'm going to post it one more time here. The HackMD file is the tutorial. You guys can follow along. It's what Miloš will be going through. Yeah, good evening to those of you in different time zones. So you can follow along here, and then it'll be about an hour. And if you have questions, I will leave it up to Miloš how you want to handle it, if you want raised hands, in-call messages, and how you want to deal with it. And I'm happy to alert you, Miloš, if there are questions that happen while you're presenting and go through. But yeah, we want it to be interactive. We want it to be hands-on. So if you're going through the tutorial, you're coding, and you want to know if there's something wrong or whatnot, just raise your hand. So Miloš can help. So I'm going to turn myself off now and hand it over to Miloš to start the workshop.
Okay.
Oh, sorry. One more thing.
Okay.
Don't forget, we want to give a few minutes at the end to run through Game of Realms and how people can
yeah. Everything has been accounted for.
Okay, yeah, thank you. Okay.
Cool. Okay. So I guess I should begin. If you guys can see me and hear me. Just like a brief introduction about myself. My name is Miloš. I'm one of the core engineers that works on Gnolang. If you've previously before this, I used to work on mostly open source projects. One of the most notable ones was Polygon Edge, which is sort of like a blockchain client that lets you deploy your own kind of blockchain networks. So now I'm working on Gno. And yeah, I feel like it's kind of interesting to give a workshop on this because it's sort of a transition from Ethereum. And I'm not sure how many people are just coming either they've like used Gnolang in the past, or they're coming from like an Ethereum ecosystem, or they have like no ties with blockchain and Web3, and they just heard that we're using Go in a weird way, and they want to jump in and see what it's all about. And yeah, so this workshop is sort of for kind of everybody. I'm actually going to show you exactly what we're going to be building. But before I do that, I really want to explain like why we're building like what we're building and what Gno actually is, and how you can use it, and how it's gonna make your actual workflow and development better. So yeah, I figured one of the best ways for me to explain what Gno is in sort of these in sort of layers of abstractions. And one of the sort of most familiar things to most developers who are either looking to get into blockchain or already doing like Web3 is they want to develop like smart contracts, right? They want to do some kind of blockchain development, either like on a low level, or they want to do application focused development that's solely focused on like dApps, right? And usually when people open up YouTube or Google and they try to find these tutorials on how they can get started, usually they sort of gravitate towards one of the biggest markets that's like currently present in blockchain, which is Ethereum. And Ethereum is, and all of the chains around Ethereum are based on this language that's called Solidity for writing smart contracts. This is sort of the entry point for most people who are getting into blockchains. So I figured I would start pretty much there and sort of ease you into Gno and ease you into Gnoland. So if you've ever been in the situation where you sort of wanted to learn how to develop blockchain applications or develop protocols for blockchains that are actually going to be executed by some kind of runtime, for Ethereum, obviously it's like DVM. For other chains, it can be some other runtime, right? But if you've ever looked into this, you've definitely sort of dibble-dabbled in Solidity. And it's sort of one of those things that's very easy to learn, hard to master. The language itself is not too difficult. The syntax is very clear. but there are a few gotchas in the language, and this is very much based on how on what limitations you're sort of exposed to when you're using DVM. And I found this like website. This website is actually very common for Solidity devs that sort of want to get into this. It sort of gives you an example of like how you can do Solidity development, how you can do map allocations, how you can do constructors, how you can do mapping, stuff like that. So just like basic language syntax, but also it has a section on the website which I think is very it's very Solidity based. It has like a list of hacks that people have used either in like Solidity compilers, EVM runtimes, or like the language exploits themselves, right? And you've either like used this resource or you've used like something like Crypto Zombies. And once you start using the language, you sort of feel very much bound to some of these design choices. The way memory is sort of allocated within Solidity, the way storage is actually kept on the blockchain. And you really need to fit into this small hole and just like learn something new, even if you're coming from Web 2. So even if you know Java, if you know Go, if you know any other language, it doesn't matter. You really need to focus on learning something new in order to develop the apps. It's either like Solidity or it's like Viper, right? And usually the contracts that you write, they're not as transparent as you would like them to be. So usually in like open source, when you have a repository, you can always like open up the code and see like the code and see exactly what the method that you're doing is actually the method that you're using is actually doing. This is more true for like C++ code and stuff like that was like precompiled for you. But most like open source projects now like have their code visible. Solidity, even though you can open source your own contract, there is no way for you to sort of inspect the code on the blockchain itself. There is no way when you're actually saying, okay, I want to call or execute any kind of method on the contract. I'm not sure exactly what kind of code it's executing. And I found Etherscan has this like useful feature where you can actually inspect sort of the code's source code, the smart contract source code. Let me admit somebody. Yeah. And this is not true for most contracts that are actually uploaded and deployed. It's actually a process that you literally need to do manually. So you need to go in here and you need to upload the original source code for you, and they do some kind of verification, and they verify that whatever is on this address on Ethereum, the contract bytecode actually matches whatever source code you deployed. But other than this, there is no real way for you to sort of know exactly what the code is doing for you. And it sort of creates two problems primarily for blockchain developers. One problem is this complete lack of transparency. Even like it sounds crazy because we're talking about blockchain systems, but it creates the sense of lack of transparency where you have no idea like what's going to be executed as soon as you interact with some contract or interact with a piece of code on the blockchain. And it creates the second problem. The second problem is it creates this like initial barrier for new people who want to come in and they want to work on, they have like an idea for a blockchain app, or they want to integrate or migrate some existing logic that they have on Web 2. They want to migrate to Web 3. And they sort of have this huge learning curve where they first need to learn like a new language, but also they need to learn all of these like different ways Solidity has been misused in the past, so they don't fall victim to it, right? And this is sort of going in the opposite direction of increasing blockchain adoptability and increasing the user experience for new developers. And sort of the Gno project is something that's aimed to solve a lot of things in like modern blockchain systems, but primarily it aims to solve this very problem of lack of transparency and accountability for smart contracts and ease of use for new developers that want to come in and that want to basically contribute to the blockchain ecosystem, right? So what is Gno? Gno stands for two things primarily. One thing is it stands for Gnolang, the language that we're going to actually use for this workshop. But it also stands for the platform that we're building. So Gno is a layer 1 blockchain that's run by the Gno VM. So the runtime is the Gno VM, and it executes smart contracts that are written in Gnolang. And Gnolang is this 99.9 identical version to Go that you can actually use to write smart contracts. And sort of the powerful thing here is, even if you're coming from a Web2 background where you've never used Go before, you've, for example, used Python, or you've used Java, or you're coming from C++, you can very easily pick up Go, because Go is very easy to pick up. You don't have to be constrained by the actual runtime like you are with Solidity. You don't need to learn about like existing hacks for the language. And you sort of have this clean slate where you can really focus on what you're developing and not have to worry about, am I using the language right? Am I optimizing this, this Solidity code to be as optimal as I can? Like I've met people whose literal full-time job is to go in for like these very big contracts that are used and optimize certain chunks of the code by either like completely extracting chunks of code out and using like assembly, just so they can like save on gas fees, right? And the Gno project sort of aims to put that aside and just give you the powerful tools of Go and the powerful tools of blockchain to develop your own blockchain applications and to sort of further blockchain development. There's a lot more to it, but this is primarily the thing the things you need to know in order to begin this workshop. Sort of prerequisites that you need for the workshop, because we're going to be going into the code soon. You need Go 1.19. That's like the minimum version that we require. I strongly advise that you do this workshop on Unix systems or on VSL2. Why? Because we use a lot of Unix tools like Makefile, Make, for like building out scripts and building on our binaries. And yeah, you're probably going to run into problems if you try to use this on Windows machines without like seriously prepping ahead. And yeah, this has been like a lot of talk and a lot of shade on Solidity, but I just, yeah, it was sort of required for me to explain why Gno exists and why we're actually doing the workshop. And now, yeah, I'm just sort of going to draw exactly what we're going to be building. So the whole point of this workshop is to build a forum instance on the Gno blockchain. So we're going to see how you can write Gno contracts, how you can test Gno contracts, how you can run Gno contracts. We're going to see how you can actually interact with them, call their methods, deploy them, change some things. And I'm going to take you from like 0 to finish on this. So you can see like the whole workflow and how we already like use these tools that we have at our disposal to like develop new blockchain applications, right? Yeah, so the general idea behind the forum that we want to build is, and I'm drawing here from looking down, we want to sort of have a system where, if you imagine this like as any kind of browser window, we want to have a forum where basically the top level split is between categories. So you can have like category 1, category 2, category 3. And when some user clicks on a specific category, they're taken to a page where, they have like specific posts, and these specific posts have either like a title, a body, and they have like specific comments, right? There's a much nicer graphic on the hack and Deem document that Michelle shared. But this is sort of the gist of it. So we want to have a post the users can create. We want to have comments the users can add to posts. We want to have this top level split between posts that are they're grouped sort of by categories, and we want to have like a special user that's called a moderator, and the moderator can appoint like different users to moderate the post, right? So they can appoint somebody to delete a post if they deem it's like infringing on any kind of policy of the actual forum. And sort of the way we're going to do this is we're going to do it in two parts. One part is we're actually going to be developing the library for this, so something that's called a package. And in the second part, we're going to be doing like the actual smart contract development, which is called the realm. And I'm going to go into details on what exactly these are. So in Gno, you sort of have this, if I can scroll down, you have this, what is the English word for it? Jesus. You have this split, sorry, between logic that's called between a package and a realm. And I hope you can understand my horrendous handwriting. A package is usually something that does not hold state. A package, you can think of a package as just like a bundle of code that does not have any kind of state keeping. It does not have any kind of query methods. You can ask it for its like specific state. You can think of it as basically just like a library that you can import, right? So just like a bundle of code, any kind of library on GitHub that you import, you can actually use it as a package, right? So it has no state, right? Realms, on the other hand, are actual smart contracts that hold state for you. So they have kind of variables that can hold state. They have methods that you can interact with them, and they are what actually powers your application, right? So this sort of split between like different code logics is very important, because we're first going to be developing this library part, and then we're going to be developing the actual realm. So I hope like the difference is clear. So packages are just like libraries; they don't have state. Realms are actual smart contracts that hold state for you. Someone has their hand raised. Yes.
Hey, hi, Miloš. Thank you for the explanation. Yeah, so if I understood it correctly, so you're saying that packages are kind of like library, and then the actual magic happens at Realms, where we write smart contracts and we use these packages, correct?
Yes.
Yeah. So
you'll see exactly what I mean. Yeah. You'll see exactly what I mean as we sort of get into the code.
Yeah.
But yes.
Yeah. So just to like clarify, so the packages are not kind of like mandatory then, because if it is library, we can write some minimal code like a basic smart contract without a library also, correct?
Yes, definitely. You don't need a package to use a realm, and also you don't need a realm to use a package. Where this workshop is sort of focused on building both, so you can understand the difference between both, right?
Okay, sure. Thank you very much.
Yeah, no problem. Okay. Yeah. So I guess we can sort of get started with the actual tutorial. Yeah. I'm just like to give you an overview of the setup they have now. I have an ID that's open. I have a fresh version of the Gno repo clone. So let me paste the repo in the chat. So oh yeah, any kind of command that I'm running, or any kind of like bigger code snippet that I'm pasting in, you can find all of the code snippets and all the commands on the HackND document that Michelle shared. But yeah, if you have any questions, just like just put them in chat, or like raise your hand when we'll tackle them in due time. But yeah, sort of the setup that I have right now is I've cloned a fresh repository inside a folder here. So it's the latest commit that we have on the current repo. And as soon as you sort of clone this repository, there are two things that you need to really do. One thing that you need to do is you need to run the make build command. And if you look into the project repository, we have this very extensive make file. And basically what running the make build command does is it builds out all of these like different binaries that we're going to use. But also, like more importantly, it makes sure that you actually download the dependencies that we have in the background, right? So just make sure you have Go 119, and they've cloned this repo, and then they have like the make tool installed in your system, and you can actually run the make build command, and it's going to build out all of these different tools that we use. And I'm going to explain like the key tools that we actually have. Okay. So now that we've actually built out these tools, if we look into our repository, we have this folder that's called build. And inside the build folder, we have these binaries that are called GnoDev, GnoFosig, GnoKey, Gnolang. These are different tools that we're going to use for development, and we're going to sort of explain the majority of them here. But one thing before we do that, you also need to, now that you've built out these tools, so they're in the actual they're in the actual build folder. You need to install these tools globally so we can just use them. You can do that by using make install. So what make install does is it runs install gnodev and install gnokey. So it basically just makes the binaries available globally from your root repository. So all of these commands are ran from the root repository of the repo. Okay. And now that you install them, you can run, you can check that they're installed correctly by running gnokey help. And it should give you sort of the help output for a command. Or you can run, for example, I think it was, yeah, it was gnodev. So gnodev help. And we can see, yeah, that this binary is available globally and we can actually run it, right? Okay. Yeah, hopefully nobody had problems with that. Okay. And we can sort of jump into like the actual code of the workshop. I'm sorry it took like so long to get to this point. If you look at the repo structure, you'll find some folder that's called examples. And inside examples, you'll find a subfolder that's called Gnolang. Gnolang has these two subfolders that are called P and R. P stands for packages, R stands for realms. And this is sort of where we're actually going to be putting our actual source code. The reason I'm sort of showing you how to the reason we're putting the source code here is I sort of want to incentivize you to, if you have an idea for a contract or a realm or a package that you would love to see, unlike the official repo or in the official testnets, you can actually make a contribution, open a PR, just like put your source code here, and we can review it, and it's going to be available to everybody for everybody to use. So if you actually open up these folders, you'll see that we already have some predefined packages. For example, if you open up examples, Gnoland P demo, you'll see that we already have like some packages. We have, for example, a package for blogs. We have a package for the AVL tree. We have a package for groups, for formatting. These are very specific libraries that we're going to actually use within this tutorial. And if you open up the realms, you can see that we have specific contract implementation. So you can think of this as very specific contracts that hold states. So for example, we have an equivalent of ERC20. We have like foo20, right? So this is like an ERC20 equivalent on Gnolang that's called foo20. Just like you can deploy any kind of ERC token that you want, this foo20 is like an example of that token, right? And like further on and further on. But for now, we're going to focus on building this package, right? So what I'm going to do is I'm going to create a new folder here. Inside examples, Gnoland P demo. So inside the demo subfolder, I'm going to create a new folder that I'm going to call forum. Okay. And inside this forum, I want to create a new file, and I'm going to call it post.gno. And take care that the extension is actually .gno, so not .go, but .gno. You can be using Visual Studio Code. We actually have I think it's like an unofficial extension by one of the core team members for Visual Studio Code for GNO that sort of sets the editor up for you, where you don't have to tell it to recognize GNO code as Go code. It just like makes your life easier. But I'm using Golang here. And I've sort of set this to recognize any kind of .gno file as a Go file, basically. So I have like syntax highlighting. Okay, so now that we've created a post.gno, this is sort of going to be our library equivalent of a specific post. So what we want to do is I want to say that this post is going to be in package forum, because we sort of put it here. And inside a package forum, I want to define a new struct, which is called post. And when you think about it, the things that we want our post to have is sort of, we want it to have an ID. It can be a UN, for example. We want it to have a title. We want it to have a body. And we want it to have a category, right? Because if you remember, we sort of divide posts into these buckets that are called categories. So each post belongs to like a specific category for this like example, right? But we also mentioned like one thing, and that is we want to basically give users the ability to actually comment on posts. So we can assume that this post is actually going to have some kind of comments, right? one more thing that we need to add is we sort of want to keep track of who is the actual author of this post. And we're going to do this by using author and specifying the type to be std address. And you can see that my ID is sort of freaking out because it has no idea how to actually import this. But I'm going to show you in a second. So what we're going to do is we're going to import std on top of the file. And it's still like showing a squiggly line because it doesn't have like IntelliSense for GNO files yet. We're still actually working on adding Gnolang support. But yeah, for now, you can import this using std.address. And std.address, and I'm going to show you exactly what the std package is. Std package, just like any kind of built-in Go package that you use, for example, like bytes or, I don't know, crypto rand, stuff like that, stuff that's already built into the language. std is sort of a built-in import for GNO. So within any kind of GNO file, you can use this import std, and it's going to be injected as this file is being parsed, right? So you're going to have access to this address right here. And yeah, for the post, so it has an ID, a title, a body, a category. It has like some comments, and it has an author. And I'm going to show you exactly how we're going to use std address and what std address actually is. It sort of ties into like the other story, right? Okay, so we want to create a function that's going to give us a post. So what we're going to do is create a function that's called new post. It takes in an ID, it takes in a title, it takes in a body, and it takes in the author, right? And it gives us back like an instance of a post. So this is like just regular Go code that I'm running right here. Okay. And I want to return just a new post where the ID is the ID that I passed in. The title is the title. The body is the body. The author is the author that I'm passing in. And the comments are just like an empty array of comments for now, right? We want to use. Okay. And additionally, we can also, for this post struct, we can also define some getter and setter methods. And just for the sake of time, I'm going to paste in these getters. So just like very basic Go, we're just grabbing, because these are private fields, we're just grabbing the ID, grabbing the title, grabbing the body, grabbing the comments, adding the comments, stuff like that. So just like very basic getters and setters, right? So if you look at this file, it's a very basic Go file. You would, if this was like a Go extension, you would not really see the difference if it could like somehow resolve this STD, right? Yeah. One thing that's missing here is we need to define, because we said that posts have like this concept of comments, right? So we can create a new file, and we're going to call it comment.gno within the same package form. And we sort of want to define it, right? So we're going to go type comment struct. The comment just has like a regular body, so nothing special, and it has like some kind of author, right? That's also going to be associated with an address here, right? Okay. And for this comment, we're going to define a constructor. It just takes in a body and returns comment. The body being the body. Oh, and notice that we didn't pass in the author. There's actually one way that you can actually get the author, because if you remember, this is a library package, but we also, it uses this concept of injected packages that we have. So STD, we can use, because we import STD, we can use a built-in method of STD that's called STD get orig caller. And what this basically does is, this is a helper method that as the GNO VM is actually parsing this contract, whoever is the caller for the smart contract that's actually using this library here, their address is going to be extracted right here. So it's sort of very similar to, I think the Solidity equivalent is message.sender. So message.sender is something that's like available throughout your contract that you can use. For Gno, you can use std get origin caller. It's going to give you the address of like the actual person that's initiating this transaction, that's calling this new comment method, right? And also for the comment, we're going to define 2 getters. So 1 getter for the body and 1 getter for the author, right? The author, of course, can return an std address. The body returns just the regular string body. Okay, and we have like this fairly simple logic. So we have a post that we can set and we can grab. We have a comment that we can create. Is there a way that we can actually figure out if this works without having to deploy like the whole library and just like write contracts to test the library and stuff like that? Before we dive into that, I think somebody raised their hand, or no? Yeah, I'm imagining things. Okay. So we're going to define a couple of tests here. One of the tests that we want to define, let's define a test for the comment first, right? So the comment is a very simple, it takes in a body, it takes in an author, it has like 2 getters. We want to test out whether or not this new comment method actually works, and whether or not these like getters work as well, right? So we're going to create a new file, and we're going to call it comment_test.gno. So exactly is the way you would sort of create any kind of test file. So the only like difference is it's .gno and not .go. This is of course going to be in the package form, and we want to write a new test. So the test is going to be test comment because we're testing the comment. New. It takes in a testing T. Okay. We can of course import this from the standard library. And we want to define a couple of things here. So we want to define some kind of body that we want to use, this comment body, okay? And we want to define an author, right? This is sort of a moment where when you're creating a comment, when you call this method, we need a way to mock this call right here. So we need to, because this method, of course, does not take in who is the author. The VM actually discerns that as it's running. So we need to have sort of a way for us to mock this std address, so that whatever is being returned here, we can actually set it, right? So std has this, well, actually std, but we have like a package within the Gno repo that's called test utils, and it gives you the ability to define something that's called a test address. One sec. Oh, give me 1 second. I have no idea. I have no idea why. What is the difference between these? But yeah, we want to use this test utils. But test utils, if you actually look here, we don't want to use a test utils that's like from some GitHub repo, right? We want to use a test utils that's also a Gno package in and of itself. And if you look into the demo folder, there's actually a package that's called test utils. And if you open test utils, it has a method that's called test address. And this test address actually is what we're actually using in this test right here. So it's going to give us the address based on some kind of input string that we give it, right? So how do we import this package, right? To import any kind of Gno package, what you would do is you would import it as any other Go package. So you would say, but instead of doing the package name, so like github.com/gno/testutils, we're going to import it using its package path. So we're going to say Gno.land /p/demo/testutils. Okay. And now we can actually use any kind of public method that the testutils package exposes, because we imported it here using the Gno package syntax, right? So what we're going to do, we said that we wanted to mock sort of this call right here, but to actually use the std address, we also need to import std. Okay, and let's mock sort of the author. So the way we sort of mock this call right here, so get origin caller, we want to put in the address that we just created here. We're going to say std.test set origin caller, and we're going to put in the author right here, and we're going to create a new post, a new comment, sorry, new comment using the body that we created right here. So what's happening basically is we're creating a new comment using this string right here. We're setting the output of this std get origin caller to some address that we know like in advance that we want to mock, right? So the way we can actually test that this works is we can check if p.get body is actually the same as body, and if it's not, then we can fail, right? So we do t-fatal f invalid body, right? And we also want to check if get author is, sorry, dot string. We want to compare the strings, author string, t-fatal invalid author, right? Okay. So basically what we're doing is we know the body in advance, we know the author in advance. When we create a comment, we just want to test, okay, has a comment been created by this author with this body? This is just like the very simple, a very simple test, right? Okay. And sort of analog to this, we can create a test for the post, right? So we can go post test.gno in the same, oh, wait, I can speed this up a bit. We can create a test for the post as well. So when creating a new post, what we do is we predefine like an ID, we predefine a title, we predefine the body, the category, the author in the same way that we've predefined it for here. We create a new post, we set the category, and we basically run these getters and make sure they return the data that that they're supposed to return, right? So the data that we passed in, we just make sure that they return it, right? So we come to sort of a problem here, and that's, okay, we have these Gno files and we have these test Gno files. How do we actually run these tests? Like if you look into your IDE or if you're using like Visual Studio Code, there's like no play symbol here for you to actually run it. There's no like fast forward button to actually run this entire test suite. And this is sort of where the tools that we installed at the beginning come in. If you remember, we installed something that's called GnoDev. And GnoDev is essentially a development toolkit that makes your lives much easier when you're developing Gno contracts. It allows you to run the specific Gno files, to precompile them, to test them, to manage a Gno mod, so which is sort of analog to Go mod. It gives you like all of these different options, and the option that we need right now is like any kind of way for us to run these specific test files, right? So the way we can run them is we can say, okay, GnoDev test. We run the test command and we say we want verbose output for here. And you can actually see the what kind of flags you can use if you run anything with the dash help. It's going to give you the default values in the flags, right? So we want to use GnoDev test verbose, and we want to give it sort of the path to these Gno test files that we have, right? So we're going to give it a path where from the root, it's going to be examples, Gnolang, p demo forum, right? And if we run this, we should see our test actually passing. And this looks like regular Go output. So it's running the new comment test, it's passing, it's running the new post test, it's passing. And it's returning a status that everything is good, right? Okay. Now that we have sort of a post and now that we have comments, we need sort of an entity instance of the forum to actually keep track of these posts, keep track of these comments, like keep track also of moderators, and just like additional metadata stuff, right? And remember, because we're building a package here, it needs to be as general as possible, so any kind of forum instance can actually use it. And this sort of ties in with the story where the realm that we're actually going to be building, so the smart contract that's going to be actually using this forum package, it doesn't have to be a forum for one specific thing. Like somebody can have a forum for cars, somebody can have a forum for Samsung TVs, right? The point is they can use this library that we built here to create their own form instance that can be completely unique for whatever they're building. So this is why we're sort of writing this to be as general as possible. It doesn't have like any kind of, it doesn't specialize any kind of data for you. It just gives you a package, and you can use this package later when you're writing your own form instance, right? Just like I mentioned, where somebody made Foo20, which is like an ERC20 equivalent coin that they deployed, right? Or Foo721, which is like an NFT, right? So what we're going to do is we're going to create, within this forum folder, we're going to create forum.gno. It's going to be package form. And within the package form, we are going to define a forum struct that's going to have a name. So any forum that people create, it's going to have a name, right? So it's going to have a posts. I'm going to leave 3 dots here because I want to show you categories. It's going to have, if you remember, the way our forum works is we sort of group posts by categories, like in these category buckets. It's going to have an admin, so it's going to keep track. It's going to know who actually create a forum, who can like make specific changes, like appoint moderators, change policies, stuff like that, right? So we got to have an admin, and we need moderators, right? And the reason I left sort of these 3 dots here is there are essentially 2 ways that we can define this. So we can, for example, if we're going naively about it, we can sort of say, okay, well, posts are going to be specifically like an array of posts, and categories, or it can be an array, or it can be even like a map that maps to some string or whatever. But there is one other way that's more optimized when you're using Gno, and this is called an AVL tree. And the way you can think about an AVL tree is it's basically a value map. So what we're going to map here is we're going to map the post ID to the actual post, right? And for categories, it's also going to be a tree, and we're going to map the category name to just this like list of posts for that category. For the admin, this is the address, and for moderators, it's also going to be like a lookup map, and it's going to map the category name to just like a list of user addresses that are moderators. So whenever somebody wants to look up if for category X somebody is moderated, they can just ask this map and just see if the address is here. Also, if you want to fetch posts for a specific category, you can look it up in the categories here. So this is sort of the reasoning behind it, right? And you probably guessed it. If you, how do we actually import the AVL tree and stuff like that? My IDE is freaking out here because it's trying to resolve this import. But if you look into the packages, AVL is also a Gno package. So AVL it's already a predefined package that we can use to create new trees, to create new nodes, to look it up. So we're not going to import using this like GitHub syntax. We're going to import it using Gno.land /p/demo/AVL. So this is the package that we're actually importing right here. And because we use std address, we can also import std, right? Okay. And just because I see we're running out of time, I'm going to speed this up a bit. Basically, what this method does is it creates a new forum instance where you as like the actual forum administrator can define a name, you can define the categories that you want, and you can define who is actually going to be managing this forum, right? So what this method does is it creates a new forum instance. So just initializes everything, and it initializes our map right here. So basically, the logic behind this method here is whoever is the admin of the forum is also sort of the moderator for every kind of category, right? So this is basically what line 39 does. And yeah, we instantiate the categories, we instantiate the moderator set, and we return like a created forum here. For the forum, we also define a couple of getter methods. So we need a way for realms that are actually using this forum package to be able to grab the name, to be able to grab the categories, to be able to grab the posts, to be able to add moderators, to remove moderators, stuff like that. So we can define all the getters. And sort of, I'm copying this off screen, but you can find this in the HackMD document shared by Michelle. So there's a method for fetching the name. There is a method for fetching the categories, and I'll get back to this in a second because it's very important. There is a method for fetching the comments, and there is a method for fetching the posts, and just getting like a specific post by the ID. So if you remember, the way we sort of use this AVL tree is we use it for a mapping, right? So we map some value, which is a string, to any kind of arbitrary value. Right here for the post, we're mapping the post ID to the post, like a specific post object. For the categories, we're mapping the name to like the list of posts, right? The way for you, for example, if you wanted to fetch what are the categories for a forum, this is just illustrative because I want to show you how you can traverse this map. It's very similar to how you would use sync maps in Go. So if you remember sync maps, they have this funky method that's called range. And range, what range does is you give it a callback method that it basically calls for each item in the map. It does like this map traversal under a hood, like by itself. But the point is, it calls this callback for each element, and you need to make sure that this callback actually returns a boolean. And this boolean actually just indicates whether or not you should stop iteration at this point, right? So AVL tree.iterate is sort of very similar. It takes in a function that you can specify that's going to be called for each element. Right now, because we're actually just want to get a list of the category names, we're just going to iterate over all of the category names and just grab them up into this array, and just continue iteration until we iterate over like this entire map. This is just for illustration purposes. I don't think anybody would write like a category grab like this, but just to show you that this actually works.
Miloš?
For a single...
Miloš,
sorry.
your microphone makes some strange noises.
Wait. Test.
Yeah,
Yeah?
good.
I will never figure this out. Okay. So this is sort of how you would iterate for each element, right? So how you would do a range on this AVL tree. The way you would actually fetch an element from the AVL tree is it has this method that's called get. And it returns, of course, it returns like an interface, so any, and you need to cast it back to whatever you actually stored, right? So for posts, when you want to grab comments for a specific post, what we do is we go to this lookup map and we say, okay, posts, grab the post that has this ID. And if you found it, just like cast it back and give me the comments back, right? And this get comments is, of course, from post get comments, right? Yeah, and sort of all of these getters are sort of based on this same idea. So you iterate, you get, you store, stuff like that. There is also one more thing. If you notice here, we have ufmt.sprintf. This is also a package that we use that's called ufmt. And because it's a Gno package, we actually need to import it here. So if we go Gno.land /p/demo/ufmt, right? Gonna sort it. Okay. And now that we have like these grabber methods, we can also define specific logic for adding a moderator, adding a post, adding a comment. And keep in mind, let me just go back. Okay. And keep in mind that these methods need to be like as general as possible. So the actual realm that we're going to be writing, so the actual forum instance is going to have a reference to a forum object that's going to be using these like helper methods to actually keep track of state, right? So if the forum instance wants to sort of have moderation, it can expose this method. It's called add moderator that the admin can call, and internally it's going to call this method right here that we defined. So add moderator simply just checks if whoever is the caller is the admin, if they actually have permissions to add the moderator, and they just set the moderator, right? Similar for posts, it's a similar story for comments also. For remove posts, it's a check where you need to check if you're the moderator, And if you're the moderator, you can remove the post, right? It's sort of a chunkier piece of code. And you can find like this entire piece on the actual like tutorial. But just for the sake of time, I'm sort of speeding through this so I can actually show you the fruit of what we've been making. And this sort of brings us finally to a point where we can actually also write a test for this. So we can say, okay, forum test.gno. And again, saving time. So we define a test where we create a new forum and we make sure that the name is correct, that the admin is correct. We have a test where we add a post. So we add like we create a forum using these parameters. We add a post with these parameters and make sure the post actually exists. We have a test for removing the post where we add a couple of posts and then we remove one. We appoint somebody as a moderator that they can remove it, stuff like that. We add a test for adding a comment. So when you create a forum, you add a post, you can add a comment. We just validate that these methods that we just wrote down work right. So basically the same way as we would test this before, we run that test verbose. You don't need the verbose. Like this is just for us to see. You put down the path to your package. Whoa. Something popped up. Let me see. I probably mistyped something. 1 second. Yeah, I probably mistyped something when I was doing here. I copied the code from the guide. So we run the test the same way as we tested forum, the same way as we tested post, so we can see that these tests are actually passing. And this basically concludes our package. And now for the actual forum, the whole point of this is we have a library that we can use now that anybody can use to create their own forum instance, right? And what we want to do is we want to create an instance of this forum that's, for example, called I don't know, like Gno overflow, right? So a specific forum where you can ask questions about Gno. What we do is we create. So now that we're finished with the package, we're going to create the actual realm that users can interact with, right? So what we're going to do is we're going to create a new folder within examples Gno.land or demo. It's going to be called, let's call it forum as well. And within this forum, we're going to create a new file that's going to be called forum.gno. Okay. And within forum.gno, it's also going to be a package forum. Okay. And I'm going to show you something that you can never do with packages, but because we're writing a realm, this is going to work. So I'm actually going to define variables for this contract. And this is the state that I was talking about, where packages don't actually hold state, but realms hold state, and they hold state during execution. So across transactions, this state is going to change. It's going to be saved, right? So what do we want to save in the state? We want to save, obviously, like the name. We can call it, for example, overflow. We want to save like who is like the actual admin. And it's going to be undefined for now. We want to save the categories that we have, right? So let's have like a general category. We can have devs, and we can have announcements. Okay, so 3 categories. We need to have a reference to the actual forum. And notice that it's giving me sort of this IntelliSense is sort of lying to me, but yeah, I can actually import the forum. The forum that we're actually going to be importing is the package that we just created, right? So it's going to be an instance of a forum. And we're just going to keep track of a post index, just like a global post index for this, right? And because we imported this, we need to sort of fix these imports. So we imported address, we need std, we imported also the forum. So how do we import the package that we just created? Well, we go Gno.land /p/ demo/forum. Okay. And yeah. And I'm also going to write a constructor method for this realm. So whenever you want to deploy this method is actually going to run. And the way you run, basically, write constructor methods is you would do func init. And I know init methods give people like the heebie-jeebies. But this is how you will write a constructor in Gno. So whenever you want to deploy this actual realm, this very specific realm that's called Gno overflow, that's an instance of a form, this method is going to run once, and it's going to initialize like this initial state you have, right? So the only thing that's sort of left for us to initialize is this forum object. So we want to go forum, f is forum.new forum. That takes in a name, the categories that we've put down, and it takes in the admin address that we specify right here. Okay. Now, because we sort of did most of the heavy lifting in the package, if you remember, our package has logic on how to add a post, how to add a moderator, how to remove posts, how to add comments, stuff like that. For the realm that we're specifically trying to deploy, we don't need to rewrite those methods again. We can just use them because they're part of this library that we just wrote. So the way we define these methods is we define a method for adding a moderator. Sorry. We check if somebody is already a moderator, and if they're we call the package method for adding a moderator. If it succeeds, we return like moderator successfully added. If it doesn't succeed, we return like some kind of error message. For the post, it's very similar. So for the post, what we want to do is we want to get the actual title, the body, and the category for the user. And based on this information, we construct a new post object. We set the category and we add it to the form. And we just increase like the global post index, so we know sort of what is the next post ID, right? For the comments, same story. The user gives us the ID, the user gives us the body, the post ID, of course, that they want to comment on, the body of their comment. We try to add it. And for removing a post, it's sort of similar. And this sort of brings us to, let me just make sure that we have the imports, the correct imports here. Okay. And this brings us to sort of this other important part, which is called rendering. And if you've sort of looked into Gno, you can see we have a public testnet that's running. I think it's the third one. And it's great because I want to sort of demonstrate what this render is. If you, it's sort of the render between packages and realms. So if you actually open up a package, packages do not have render methods. The whole point of a render method in Gno is to sort of allow users to have a visual insight into the actual state of your realm. It can be anything you want. So your render method for realms can display any kind of message that you want. It can display the internal state, as we're just going to display, or it can basically not be defined. You don't have to define a render method for your realm. But just to give you sort of an example, the way you would, for example, view a render method for Foo20. So the render method for Foo20, if you open it up, the render method displays basically which accounts actually minted this token, what is like the total supply, how many decimals it has, right? So this is an example of render method. Another example of render method would be users. So if you open up users, it gives you a list of users, and you can click here on a user, and you can actually see like some kind of information on them, right? But these are specific render methods that are created for these specific contracts, and it can be completely different from one another, right? For demo, it doesn't make sense, and you cannot define a render method for a package because it doesn't have any internal state that it needs to render. For packages, you can actually see the source code. You can actually see exactly what you're importing and exactly what you're running. So the code you see here is the code that's actually being imported when you actually import it into your realm, right? So this render business is what we're going to be focusing on next, is sort of bringing this workshop to a close. And you can find the details on this render method in the actual forum post. But basically the gist of it is this. We want to have any kind of realm that wants to show off this logic. It needs to define a method that's called render that takes in a path, which is a string, and returns a string. And the very important part here is this return string can be in Markdown, meaning you can actually format it, you can make it look nice, you can add line breaks, you can add titles. And this is actually what we're going to do for our render method. So we want to say, okay, if somebody opens up the base, so the base URL of our realm, we want to render some kind of homepage, right? So if I think I deleted my ugly drawing, but the homepage for our forum is going to have like categories where users can click and they can be taken to a list of posts, right? And if they're on a posts page, we want to render, if they're on like a specific category page, we want to render the posts, right? And if they open up a specific post, then we want to render the post with the comments, right? And I'm just going to, it can be very confusing if you're looking at this and you're saying, okay, length of parts is 2 and parts of 0 is post. What this basically means is if somebody opens up for the path to be the homepage, it needs to be our demo forum, right? Because we're going to deploy our realm here, right? This is just like the base. But if somebody opens up our demo forum and they say, okay, post/0, they want to view the post ID 0, the post with ID 0. This is basically what it means. This post here means that we're doing this like string matching where we say, okay, somebody wants to view a post with the ID 0, right? And we grab this from the second part right here. The analog is sort of for the category. So if somebody wants to view a specific category, they can do it like this. So we match the category for part 0. For parts 1, it's going to be the actual category that they want to view, right? And to sort of make this, I'll sort of paste these methods for rendering in a second and show you exactly how they work. But before I do that, I need to fix one thing. And this is, I need to add this forum prefix because we use it. It's sort of, oops, 1 second. We use this forum prefix later for rendering, and I'm going to show you how we use it in a second. And just to make sure our imports are okay, I'm just going to copy this. Okay. So if you go into render and you see, okay, we want to render the homepage. So for the homepage, really what we need is we want to display the name of our forum. We want to display the categories, but we want to display the categories as links. So when somebody clicks on a category name, they're going to be taken to a specific page where they can actually view the posts, right? So what we're going to do is when we want to render a homepage, we want to gather, basically we're constructing this markdown as we go. So we're going to construct like a header that says, welcome to our forum. And for each category, we're going to create a link that links back to that category. And the way we sort of construct this link is we use this forum prefix to basically let the router know when somebody clicks here, they want to view that /r/forum :category/ and the category name, right? And this is the same, it's the same idea for the posts. And it's the same idea for rendering comments. So when you want to render a comment, it just constructs markdown for rendering a comment right here. Okay. And yeah, I can actually show you how this works and how we can use it. So the bulk of our logic was in the package. The only thing our forum actually contains is this constructor where we create a forum and these methods that we expose that people can actually call. People can't call directly the package methods, right? Because this is just library. But they can call realm methods, and this is sort of how to do it. You expose them, and people can call them using their own, using the parameters, right? Okay, and yeah. So we come to this point where we've written down the realm and we've written down the package. but we sort of want to deploy them and we want to interact with them and we want to see how they actually work. And to sort of interact with any kind of blockchain, like even for deploying Solidity code, you need to generate something that's called a private key. And a private key is something that's associated with the address that you're using on the actual blockchain. Hopefully, luckily, we have a tool that we created earlier that's called Gnoki. And one of the cool things about Gnoki is that it has this subcommand that's called generate. And it also has subcommands for like exporting, importing private keys, stuff like that. But if you do not have any private key that you can use and any address that you can use, we can run Gnoki generate. And what Gnoki generate is going to do is it's going to generate a BIP39 mnemonic that we can actually use to derive the private key. So what we're going to do is we're going to go say, okay, Gnoki add -- recover. And we need to sort of give a name to this key. I'm going to name it admin key. So what we're doing is we're going to say, okay, Gnoki, I want to add a new key that's going to be called admin key. The recover flag basically instructs Gnoki to ask us for a mnemonic that he can use to recover the actual address and private key, right? So what we're going to do is we're going to copy this mnemonic that we generated. We're going to run a Gnoki add. It's going to ask us for a passphrase to encrypt the key on disk. Just give it like a simple passphrase. And it's going to ask us for the BIP39 mnemonic. I'm going to copy this that we generated earlier. And it's going to generate a key for us that's called admin key, and the address is G18 and NVC, blah, blah, blah. The way you can see all of the keys that you have is you can run a Gnoki list, and it's going to give you a list of keys, right? Okay, now that we have a key, to actually deploy the contract, we need some kind of native currency funds, right? And there's two ways that you can sort of generate funds. One way is to pre-mine them. So if you look into, I'm not exactly sure where the file is. Yes, so if you look into Gno.land, the root repo Gno.land Genesis, there's a file that's called Genesis balances. And Genesis balances is essentially the initial balance sheet that's going to be applied when somebody actually starts the blockchain network, right? So we want our address here that we just generated to have some funds when we actually run the network. This is one way of getting funds. The other way is by creating a faucet. If you actually look on the official Gnolang website, what we have is, I'm not sure where is the faucet here. Yeah, we have like a faucet that you can add your address and you can get some test funds, right? And you can sort of do the same on your local network where you can spin up a faucet locally and just have it, instead of like pre-mining for one address, you can spin up a faucet and just have the faucet basically dish out funds for you. So what we're going to do, but just for the sake of time, we're going to duplicate this last line in Genesis balances. Oops. And we're going to put down the address that we just generated. So we want our address to have this many tokens, this amount of native currency. Sorry, as the blockchain starts. Okay, and now the blockchain is not yet started. The way we can start the blockchain is by start like the actual node, right? Is by running the Gno.land command from the build folder, right? So this is all you need to do. You run it. What it's going to do in the background is it's going to go through the list of all of these balances and the list of these Genesis transactions, and it's actually going to spin up a network for you, right? So right now it's a running network locally, and we're just going to leave it in the background. And one way we can sort of figure out whether or not our balance worked is if we whether or not we have like funds for our address, is we can run this command. It's called Gnoki query. What the Gnoki query command does is it sort of, you specify a remote node location. Our node is remote, but it's on our local machine, so it's going to be localhost 266.57. you want to give it the query address that you want, and just be sure to replace the last part of this query with your actual address right here. And when we query this, we can see, okay, our address G18NVC has this amount of native currency, so we can actually start deploying and start using the realm, right? Okay. So I'm going to open a new tab here, and I'm going to spin up the Gnolang website. So this website is for our testnet. I don't want that. I want to use a local website so I can actually inspect the realm and package. So I just ran build website, and it's going to spin up a website that's running locally. So this is like a local instance of the website that's connected to the node that's running locally on the machine. Okay. So how do we actually deploy the package that we have? So we can make it available to everybody else, and how can we actually deploy the realm? The way we can deploy a package is we can run a command that's called Gno key make transaction, and we call the commands the subcommand add package. I'm just going to walk you through these flags right here. You can find all these commands on the tutorial. So we're specifying the package path, so where we want to actually deploy this package. We're specifying where the source code actually is. We're specifying the initial deposit. We're specifying some kind of gas fee that we want to pay, and sort of the gas limit that we're willing to pay. We want to broadcast its transaction. The chain ID that we're going to be hitting is going to be dev, because it's a local node that's running right here. And the remote address, the RPC address of this node is going to be a localhost 266.5.7. And of course, the final argument is going to be the key that we're actually going to be using to do this deployment. And if you remember, this is the key that actually has the funds that we've pre-mined already. So if you run this, it's going to ask us for the key password to decrypt it from disk. We enter the password, and we can see that it was successful. So now if we actually open this up, and we go, and we go to, so our initial address, we go pdemo forum. We can actually see the source code for the contracts that we were doing in this workshop. We can see the test. We can see everything else. And okay, so how do we deploy the actual realm? And if you remember, in the realm code, I sort of put down these little 3 dots here for the address, because I wasn't sure what the address was going to be. I want to put down when I'm deploying this realm, because I want sort of this address to be the managing address for this specific smart contract. I can put down this address here, and I'm going to be sure that when this realm is deployed, this address, or rather whoever owns this private key, can actually interact with this realm. So the way we would, now that we've sort of updated everything, the way we would actually deploy this realm, the smart contract, is it's actually the exact same way that we would deploy a package. The commands are identical. The only difference is now we're not deploying a package, we're actually deploying a realm that we have locally. And of course, we're going to use the admin key that has funds. We enter the password, and we've deployed the realm. And we can actually see how the realm looks like. And this is sort of where that confusing render business took place. If we open up this address, we're going to see the method that we define here that's called render homepage, right? So render homepage, what it's going to do, it's going to say, okay, welcome to this forum. Here are the categories. And if we click on a category, it's going to say, well, I don't have any posts yet, right? Because we don't have any posts yet. But this is sort of the whole point behind the render method, is you can actually, in Markdown, display for the users visually the state of your actual realm or smart contract. And just so this isn't too dull, we can add a post. The way we can add a post is, if you remember right here, this forum realm exposes a method that's called add post, and it takes in 3 parameters. One parameter is the title, The second one is the body. The third one is the category. How would we actually call this method? So we can use Gno key, make transaction call. We specify the exact path where we deployed, like what realm do we actually want to interact with. We specify the function name that we want. So we want to call add post, and we specify the arguments in order as they're listed. So we want to say, okay, I want to create a post that has my awesome post title. The body is going to be this one. It's going to be for the general category. This is the fee I'm paying. This is the gas limit. I want to broadcast this on the developer chain on this like local running node using my admin key. This is what I want to execute this transaction with. I run this, enter the password, and we get a success message that says post successfully added with ID 0. And if we sort of go around here, we can say, okay, well, I added this under general. And if I open the general, I can actually see a list of posts that are added. So for announcements, we don't have any posts, but for general, we have like one post that we just added. And if we open it, we can see the post that we just added, right? So my awesome title that has like this lorem ipsum, and it doesn't have any comments yet. And the way we can add a comment is we can run the way we can add a comment is we can run also make transaction call. This time we're calling the method add comment. We want to add a comment to the post with ID 0. And this is the comment that we want to add. We run this. We get comment successfully added. And if we refresh this page, you can see that this comment sort of shows up. So this is just like a minor example of how the render works is this was, I think the bulk of this realm is just like figuring out how we want to render this to users, and users can actually now, for these like specific buckets, they can go in and they can see the posts and they can see the comments, and they can have like additional functionality that you're actually just bound by whatever you sort of specify right here. Okay. Oops. Okay, I think that was it for the tutorial part. Does anybody have any questions? I'm sorry this took so long.
Did you see some of the questions in the chat from Shankar and CodeLaw? Maybe you already addressed them. I wasn't sure.
So Shankar says the render method will only be present for the smart contract that is realms. Yes. So as I mentioned, like the only reason why you would actually have a render method is because you want to display some kind of internal state for your contracts. You don't have internal state for packages. So you only have like your realms are the ones that actually have these variables here, right? 1 second. CodeLaw says deploy realm within error version. How to redeploy? I'm not sure. Can you post the error version? Okay. Samuel says, is there a tool to compile Go to Gno? We don't actually have a tool to compile .go files to .gno files, but we do have a tool to precompile .gno files to Go files. I'm not sure if that's been done automatically here. 1 second. Okay. So if you look into GnoDev, one of the subcommands that it has is called precompile. And what you can do is you can say GnoDev precompile, and you can sort of give it a path to whatever .gno file that you want. So for example, this is going to be this realm that we, whoops. 1 second. Let's put it, yeah, forum.no. Yeah. So we want to precompile this forum right here. What it's going to do is it's going to take your .gno files and it's going to precompile them into .go files.
Your mic make
So you
noise
can actually
again.
see. I'm sorry?
Your mic may make noise again.
Oops. Is it better now?
Yeah, thanks.
Yeah. So what this precompiling does is it precompiles your .gno files into .go files, but it also recursively precompiles any kind of, like, for example, we import a UFMT package, it locally precompiles it into Go, right? So you can actually run this test and stuff like that. What is it? Is there any module available in Visual Studio? Yes. So we have an unofficial module for Visual Studio Code. It's actually made by one of the core contributors, Hariam. So shout out to Hariam. Let me see visuals. Visual extension. Yeah. I'm not sure. It should be on the awesome Gno, right?
Yeah. We should remind him. And yeah, guys, in general, if you find good content, feel free to open PRs on awesome Gno, even if that's not your content, even if they're just a tweet. For us, it's a kind of very easy distributed way to contribute to global documentation.
Yeah. We do. I think I have like I don't think I have Visual Studio locally, but if you search for Gno.land in the marketplace, you'll find it. It's like the only extension that's called Gno.land in the marketplace. It has like these. It allows you to do this precompiling like behind the scenes. It gives you. It doesn't give you IntelliSense yet, but it sort of gives you code highlighting and stuff like that. So you wouldn't have like these problems that I have with the ID, where I sort of have these like squiggly lines. You won't have this problem with Visual Studio Code. Is there a possibility that a contract can be updated once deployed on the blockchain? Yes. Update it in terms of you want to update the local state. Like, for example, you want to change the name, you want to change who is the admin, you want to change something like that. Yes, you can update it. It's like any kind of you just define like a specific method that you want. For example, you define a method that's called change name, and somebody calls change name with like the new name, and after the function executes, it's going to have the new name, right? So you can update local state. And the fourth question was, is it possible to render HTML labels with style on the render method? I think so. I think we actually have one of the contracts that actually does this. Let me find it. See if I can find it. No, it's not the faucet. It's the no. I can't remember, but we actually had like a really beautiful render method by some contributor for a package they wrote, for a realm they wrote, sorry, where it used like this kind of HTML styling. So I think it should be possible to render HTML labels in the render method. But your safest bet is Markdown. Markdown is like full Markdown support is here. Does anybody have any other questions? Let me check the Q&A. No questions. Okay. Also, yeah.
We're at the. Yeah, so I will. Thank you, Miloš. Thanks for everyone attending. This will go on the Gnoland YouTube channel. So I'll send it to the list of registrants from the workshop once it's up. And then if you guys are interested in having a further one, just let us know. Also, I posted the link for the Game of Realms GitHub. So you might want to check it out.
Yeah. Let me see.
And I think that's a wrap.
Yeah. This is actually one of the most important parts of this workshop. We should have probably
Game
done
this.
Yeah, for Game of Realms. So just like give people an overview. Game of Realms is this essentially two-phase competition that we're doing for Gno. So if you're a Go developer, or if you're a blockchain developer, or you're just like somebody who's enthusiastic about contributing, we have this sort of challenge system where if you find if you want to contribute in any way, so you can write guides, you can write blog posts, you can open PRs, you can fix issues, you can even if you're not like if you're not like a programmer per se, we also have like great discussions. Like we have regular discussions on governance proposals. we have discussions on sort of how DAOs in the future are going to be organized. You can check everything out on this like GitHub issue. I think it's actually pinned if you open issues. And these sort of link back to all of our biggest challenges. One of the biggest challenges is writing the evaluation DAO. The next big one is this governance module, but we also value any kind of contributions where you write a small guide or open a PR or fix an issue or even like let us know about an issue, right? Yeah, and it's been sort of, it's still ongoing. We're still in phase 1, and phase 1 is sort of about building the infrastructure that we need for phase 2, and phase 2 is going to be about various topics. And yeah, if this seems like something that's interesting to you, if you would like to contribute anyway, either in code or with your discussions, we're very active on GitHub. Everything we do is public. We're also very active on Discord, so you can join our Discord server. We have actually a link here on the official README. And yeah, we host like bi-weekly calls with the community, AMAs, stuff like that.
I was going to say, plug for the, we have office hours bi-weekly.
Yeah.
I think the next one is not next week, but the next week. And next week we host the developer call, which is an opportunity to listen to our core contributors and our core team, and hear what they're up to and what they're doing. So yeah, thank you everyone for your time, and I will send a little bit more details in an email follow-up. Thanks, Miloš. Thanks, everyone. See you on the next one.
Yeah, thank you, guys.
Thanks,
Talk to you soon.
Miloš.
Thanks.
Bye, guys.